start a new chapter, that is real numbers. So this is chapter 1 in class 10th. So let us start this chapter. So first of all, in previous classes we learned about number systems. Okay, in this chapter we are going to study about Euclid's division lemma, fundamental theorem of arithmetic, rational number and a decimal expansion, terminating and non-terminating decimals, irrational number, properties of logarithm and their expansion. So this is the part 1 of this lecture, and we will be studying about Euclid's division lemma. Okay. So first of all, we will learn from basics. So first of all, let us know set of natural numbers. What are natural numbers? Natural numbers means it is a counting numbers, right? We'll count on 1, 2, 3. So for now, I have 3 pens. How many are? 1, 2, 3. So I am counting these pens. So set of natural numbers means counting numbers, right? Natural numbers can be denoted by n. So set of natural numbers n is equals to 1, 2, 3, 4 and so on. Set of whole numbers. Counting numbers with 0. Counting numbers including 0 is called whole numbers. And whole numbers can be denoted by capital W. W is equals to 0, 1, 2, 3, 4, so on. Okay, now we'll talk about integers. So first of all, let us study about location of integers, right? Suppose, let us take a number line, right? It is 0, and right hand side of the number line consists of positive integers, and left hand side of the number line consists of negative integers, right? So set of positive integers. Integer can be denoted by z. Now we are discussing about positive integers. So z plus is equals to 1, 2, 3, 4. So these numbers are right hand on the number line. Okay, and set of negative integers. So on number line, negative integers are on left hand side. So as we know, integer can be denoted by z. We are talking about negative integers. So z minus is equals to minus 1, minus 2, minus 3, minus 4 and so on. Okay, set of rational numbers. What is rational number? In simple language, we can say rational number means which are in the form of p by q. And we will learn further about rational number in this chapter. For now, basic definition of rational number is a number which is in the form of p by q. Okay. Now, for example, let us take an example. Yes, 5 by 11. It is in the form of p by q. P by q, or we can say it should be in the form of fraction, right? So this is an example of rational number. So now let us see set of rational numbers, right? Set of rational numbers. So rational number can be denoted by capital Q. So Q is equals to 1 by 2, 3 by 5, minus 5 by 11, minus 7 by 12, 4 by 9, minus 10 by 5, 1 and so on. So in rational numbers we can take negative numbers also, but they should be in the form of p by q. Let's take minus 4, minus 11. It will be positive. This is one example. And minus 4, let's take 15. This is in the form of p by q. So it is a rational number, right? We can take 0 also, because it can be written in the form of p by q. How? We can write 0 as 0 by 1, and again it will be equals to 0, but it is in the form of p by q. So it is a rational number. We can take 1 also, because 1 can be written as 1 by 1, right? So it's a rational number. It is a rational number. So now let us discuss about set of irrational numbers. So first of all, what is irrational number? We'll discuss about it. Okay, irrational number means in basic language. Further we'll discuss about irrational number in this chapter. more in detailed manner, right? Basic definition of irrational number is the numbers which cannot be expressed in the form of p by q, right? They are irrational numbers. Irrational numbers are denoted by q dash. Okay. Set of irrational numbers q dash is equals to root 2, root 3, root 7, root 5, and so on. Okay. As I said, in this part, we will be discussing about Euclid's division lemma. Right? So now, from basic to advanced level, let's move on. First of all, let's know what is Euclid's division lemma by simple definition. Right? Euclid's division lemma. Given positive integers a and b, a is dividend and b is divisor, a is greater than b. There exists unique pair of whole numbers q and r. Q is quotient and r is remainder, right? Satisfying the relation a is equals to bq plus r. This relation is very important in solving the problems. Where 0 is less than or equal to r, r is less than b. This is called Euclid's division lemma. See, I underline this both equations or relations. These relations are very important while solving the problems in exercises. So first of all, a is equals to bq plus r. So let's understand this relation with an example of division, right? Let's take example. Let's take 2 and 12, right? Directly can write 2, 6 are 12, 0. Here 12 is a dividend. 12 is a dividend. I can write it as a. 6 is the quotient. Quotient is q. 0 is the remainder, right? And 2 is the divisor. So here b is the divisor. So let's work on it. Let's apply this relation to this a. It is dividend. 12 is equals to divisor into quotient plus remainder. 2 into 6 plus 0. 12 is equals to 12. So this relation is true. So now we have another relation, that is here we have another relation, that is 0 is less than or equal to r and r is less than b. This relation says that remainder should be greater than 0 or remainder should be equals to 0 and remainder should be less than the divisor, right? Remainder should always be greater than 0, because if it is less than 0, we will get negative values. So remainder can be negative, okay, and remainder can be equal to 0. Just now we saw an example, 12 divided by 2. There we got remainder equals to 0. From there we can say that remainder can be equals to 0. And remainder should always be less than the divisor. So this is one important relation in solving the problems, right? So Euclid's division algorithm or Euclid's division lemma is basically used in finding highest common factor, right? So we will discuss more about this chapter in next part. Thank you.